All right. Good morning, everyone. Today, guys, we're looking at special cases. You guys have learned in Mr. Levarchik's class, guys, there's two special cases here of systems of equations. There's cases where there are infinitely many solutions, and there are cases when there are no solutions. Okay, guys, infinitely many solutions, we learned infinitely many solutions. Those equations will actually end up um, being the same, the exact same. Okay, for a no solutions problem, we found out that those are parallel lines. So slope is the same, y-intercept is different. Okay, so we've learned about these. I want to just take some time and go over a couple of the problems for you. So these first two problems, they say determine whether the system has one solution, no solution, or infinitely many solutions. One of the ways of doing this was solving for y. Okay, taking each equation, so I'll take this top equation and I'm going to solve it for y. I'm going to zoom in a little bit. And so that means I want to get y by itself, so I'll subtract x. That gives me 6y equals negative x plus 3. And divide by 6. Y equals negative 1/6 x plus 3 over 6 is 1/2. Is that right? 1/3. It's 1/2. Okay. So that's that first equation. The second equation, I want to find out what that is if we solved it for y. And so we'll do some very similar steps here. Try to get y by itself. So to get rid of subtracting x, we'll add x this time. So negative 6y equals x plus 6, divide by negative 6. And we have y equals negative 1/6 x. 6 over negative 6, that's negative 1, so minus 1. All right? So solving both those equations for y, we see that they have the same slope, negative 1/6. Okay? The y-intercept is different. So these lines are not exactly the same. But because the slope is the same, that means that these two lines are parallel. Same slope, different y-intercepts. So they're parallel lines, which means that there are no solutions, no points where they would intersect, no solutions. Okay. Mr. Levarchik was having you guys practice a few. Maybe you guys can practice two, doing the same thing. It's a little easier. There's less fractions, so I think the solving for y is a little easier for you guys there. Again, if you had the exact same equations when you solved, there'd be infinitely many solutions. If you had same slopes but different y-intercepts, no solutions. Okay. All right. Guys, these systems we're going to solve by graphing, but these systems aren't solved for y. At least not the first couple here. So, let's take a look. Number 3, we have the equation. I'm going to go black for this first equation. 4y equals negative 7x plus 16. Solving for y, we got to divide by 4 both sides. We've got y equals negative 7 over 4 x plus 16 over 4 is 4. Alright, so let's plot that. That's a y-intercept at 4. The slope going to go down 1, 2, 3, 4, 5, 6, 7, down 7, right 1, 2, 3, 4. Okay, so that's the graph of the first line. Well, what if we graph the other line? Similar, guys. We're gonna solve it for y. Okay, let's add 4 first. So we've got y plus 7/4 x equals 0 plus 4 is 4. We'll subtract 7/4 x. And we've got y equals -7/4 x. And that's a plus 4, positive 4. Hey, guys, these equations, they're the same. The y-intercept at 4. Slope down 7, right 4. Guys, these, if we graph them, they're the same line. So there are, handwriting's terrible here, infinitely many solutions, guys. And that infinite number, I know that can be kind of tough for us to wrap our minds around what's infinite. Okay? Well, it's never ending, guys. It goes on forever. And the reason that is because lines go on. That's why we draw those arrows. They go on forever in either direction. Okay? So any point on that line makes both of these equations true. Okay? Okay. Taking a look here. I think an example of solving, I think we've done 2 nice examples, okay? Again, if you're going to have parallel lines, those are going to have no solutions. If you have the same line, infinitely many, okay? Want to give you guys plenty of time to work on the assignment. I'm going to put 3 or 4 questions up for you guys to work on today. So, all right, thanks for watching, guys. Good luck. If you guys have questions, you guys can always send me a message.